Hi everyone and welcome back to Maths and Physics with Mr. Simons. This organic chemistry reaction lesson. Sorry, my apologies. In this organic chemistry lesson, we're looking at types of reactions, right? So whether it's hydration, dehydration, halogenation, etc. Right? We're taking it from November 2018 and it's normally question 4. Some papers, older papers, it was question 3. Right, so 3 reactions of organic compounds from the same homologous series are shown below. So reaction 1, we have butane reacting with bromine to form 2-bromobutane plus generally HBr, pentane plus excess oxygen, heat, hexane to form C2H4 plus Q. 4.1.1, define the homologous series. Name the type of reaction represented by 1 or either. Write down the formula of the inorganic compound P. Give the structural formula of a positional isomer of 2-bromobutane. Using molecular formula, write down the balance equation for reaction 2. Right? So, homologous series is a series of organic compounds that can be described by, very important, same general formula or functional group. Right? So if they have the same general formula or functional group, it's a homologous series. So what I mean is either, so we check whether it's a alkane, alkene, alkyne, alkane, etc. Right, now name the type of reaction represented by I. So I'm taking butane and it's reacting with bromine, so bromination. Or if I take into account that bromine is a halogen, we can also say halogenation. One short substitution, because one bromine is gonna take up the place of hydrogen there and displace that hydrogen, and the other hydrogen that's displaced combines with bromine to form HBr. Right? So there, reaction, substitution, halogenation or bromination. Write down the formula of the inorganic compound P. So P, as I said, the hydrogen that's displaced there combines with the other bromine that's left here to form bromic acid or HBr. Right? Then 4.1.4, give the structural formula of a positional isomer of 2-bromobutane. So isomer, they have the same molecular formula, right? But different here, positional, different functional group, or different position of the functional group in short. So bromine, instead of being on the second carbon, now it's going to move to the first carbon. So they have 1-bromobutane. Right? So that's a structural formula of positional isomer. Right? So instead of 2, it became 1. Next question. Using molecular formula, write down the balance equation for reaction 2. Right? So number 1, any alkane that reacts with oxygen will always form carbon dioxide and water. Right? So there we have C5H12, right, which is pentane. So pentane reacts with oxygen in the presence of heat to form carbon dioxide and water. We have to balance it, so we always start first, because it's organic compound we're working with, we'll start with the carbon. So there I have 5 carbons and here I have 1 carbon. So to balance my carbons, if I have 5 there, I have to put 5 here in front of C. Right, so there you see 5 carbons now and 5 carbons. I've written 5. Right, my hydrogen. So my diatomic molecule starts by hydrogen, then nitrogen, then oxygen, then fluorine. So we balance it in that order. So my hydrogen here is 12 hydrogens. And you have 2 hydrogens. So to make 2 hydrogens 12, I need 6. Because 6 times 2 would give me 12. Right, so there in front of H2O, I'm going to put 6. So they have 6, so now I have 12 hydrogens. 12 hydrogens. I have 5 carbon, 5 carbon. They balance. Right, but now 5 times 2 gives me 10 oxygen. 6 plus 1 gives me 6 oxygen. 6 plus 10 oxygen gives me 16 oxygen, right? So to make 216, that's going to be 8 times 2. So 8 in front of O2 there. So I put 8 there. Now everything is balanced. 5 carbons, 5 carbons. 12 hydrogens. 6 times 2, 12 hydrogens. 10 plus 6 gives me 16 oxygens. 8 times 2 gives me 16 oxygens. And therefore my equation is balanced. Right, so this is generally a compulsory exam question. We will test combustion reactions where we take an alkane, react it with oxygen, and you need to remember the products formed will always be carbon dioxide and water. Right. 4.2, study the flow diagram below. So 4.2.1, they want the IUPAC name of compound R. So I have 2-bromobutane undergo hydrolysis to form compound R. Right, so we need to know for hydrolysis, we're going to say 2-bromobutane plus water to form butan 2-ol. So we're going from alkane to alcohol plus hydrobromic acid. Right, so there 2-bromobutane plus water, hydrolysis generally salt plus water, and yet forms the alcohol plus acid. So compound R is butan 2-ol, the alcohol, butanol. Right, so there 2 marks. 4.2, compound R reacts in the presence of concentrated phosphoric acid to form an alkene. Write down the structural formula of the major product in this reaction. So to go from an alcohol to an alkene generally involves some loss of water or dehydration. Right, so dehydration or elimination reaction, we have butan 2-ol became butan 2-ene, so therefore it had to lose water. Right, and if you don't believe me, those, as you get older and you get in the habit, if you drink too much, you feel very dehydrated the next day, so you lose a lot of water. Right, so butan 2-ol would form but2-ene plus water. So the major product here is but2-ene. Right? So there, but2-ene drawn. But 4 carbons, 1, 2, 3, 4. 2 meaning my double bond is on the second. That 2 comes on because I started with alcohol that had a OH at the second carbon. Right? And there, 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Right, so hope you follow, hope you understand. Wish you nothing but the best. Continue practicing. God bless. Bye.